Howdy friends, welcome to All About Relay channel. In this video, we will be seeing about AI, the artificial intelligence which changing the world.
Welcome to a sweeping journey through time as we delve deep into the intriguing story of artificial intelligence, this amazing technology that has been persistently shaping our world and its captivating history is an adventure we'll embark on together. From the initial theoretical concepts to the innovative applications we see today and the endless possibilities it offers for tomorrow, AI is certainly a pivotal cornerstone of the era we live in. Our narrative commences in the mid-20th century, a time when thoughts of AI were just beginning to sparkle in the minds of a handful of forward-thinking individuals. A particularly significant figure in story is the renowned British mathematician Alan Turing. Turing, with his brilliant mind, proposed an intriguing question that would set the tone for the future of AI. Could machines really think? This was no simple query, but rather a groundbreaking concept that challenged the very essence of intelligence. Turing didn't just pose this question, he proposed a test, a kind of litmus test for artificial intelligence, known as the Turing test. It set a standard for machine intelligence. The premise was simple yet profound. If a machine could engage in a conversation that was indistinguishable from a human interaction, then it could be considered intelligent. His proposed Turing test set a benchmark for machine intelligence. If a machine could engage in a conversation indistinguishable from a human, it might be considered intelligent. Fast forward to 1956, where the Dartmouth Conference became the birthplace of AI as a research field. Nestled in the serene campus of Dartmouth College, a group of brilliant intellectuals gathered to discuss what was then a relatively unknown subject. Among them were the pioneers who would soon shape the course of artificial intelligence. John McCarthy, an ambitious mathematician and computer scientist, led the pack. With his exceptional thought leadership, he was able to bring together a team of unprecedented geniuses. His vision was simple, yet profound, to lay the foundation of a field that would later revolutionize the world. Marvin Minsky, an advisor at the conference, shared McCarthy's passion for exploring the untapped potential of computers. His contribution to this pioneering group was his unique perspective on how AI could be applied to problem solving. Then we have Nathaniel Rochester, another enigmatic figure at the conference. Known for his work on the IBM 701, the first large-scale digital computer, Rochester brought technological expertise to the team. His focus was on perfecting machine learning processes and developing algorithms that could mimic human intelligence. Claude Shannon, fondly known as the father of information theory, was an integral part of this gathering. His knowledge of electrical engineering and cryptography allowed him to provide valuable insights on knowledge representation in AI. Together, they began to explore the intricacies of symbolic AI, focusing on problem solving and knowledge representation. As we move into the 1980s and 1990s, we find the rise of expert systems, AI programs that were designed to mimic human intelligence in specific domains. These were complex systems created by computer scientists and engineers that integrated sophisticated algorithms into their frameworks with the aim of replicating human decision-making processes. The whole idea was to manufacture intelligence, to build systems that could understand, learn, and respond as humans would in similar situations. These expert systems became a significant part of the technological landscape. They were used in an array of fields, ranging from medical diagnostics to financial forecasting, from data mining to airline scheduling. These systems were an integral part of the AI revolution, a testament to the advances made in technology and the evolving understanding of human cognition. Yet, despite their sophistication and the potential held, these rule-based systems had their limitations. They could only operate within the constraints of their predefined rules, unable to adapt or learn from new situations or data. This was a serious drawback, as it restricted their application and efficacy. This inherent shortcoming in expert systems, coupled with the ever-increasing complexity and unpredictability of real-world scenarios, led to a renewed interest in other AI techniques. It triggered a resurgence in the exploration of machine learning, a subfield of AI that focuses on the development and application of algorithms that enable computers to learn from and make decisions based on data. Consequently, the development of neural networks became an area of intense focus. These networks, by the intricacies of biological brains, were designed to mirror the human brain's capacity to recognize patterns, learn from experience, and adapt to changing circumstances. This marked a significant shift in the field of AI, heralding a new era of research and development. However, the limitations of these rule-based systems led to a resurgence of interest in machine learning techniques and the development of neural networks inspired by biological brains. Enter the 21st century, where the explosion of data and advancements in computing hardware unlock the potential of sophisticated machine learning algorithms, particularly deep learning. This era, brimming with technological innovations, marked the rise of transformative era in the realm of artificial intelligence. It was during this time that an overwhelming amount of data, the lifeblood of AI, started to flood our digital universe. This vast data, coupled with the rapid advancement in computing power and hardware, digitally fueled the engines of machine learning algorithms. The most noteworthy among them were the deep learning algorithms. Armed with the ability to learn from vast amounts of data, these algorithms were the first of their kind to mimic the human brain's own learning patterns. This was a game changer. Their complexity, depth, and the ability to extract patterns from data were truly unprecedented. As a result, AI began to slowly but surely transition from being confined within the reclusive research labs to becoming a tangible reality in day-to-day applications. Transition was nothing short of a digital revolution, reshaping the landscape of technology as we knew it. It was during this time that we began to see the first glimpses of AI-powered technologies gradually seeping into our lives. Fast forward to today, AI is integrated into our daily lives. We interact with it more often than we realize, from virtual assistants like Siri and Alexa to recommendation engines such as those used by Netflix and Amazon, to facial recognition systems at airports, to autonomous vehicles making our commutes easier. AI has indeed come a long way and will continue to shape our future in ways we can only imagine. One of the most exciting current developments in AI is generative AI, a technology that enables AI systems to generate creatively compelling and authentic text, code, images, and other forms of media. Generative AI is the product of arduous efforts of computer scientists and data analysts who have leveraged large-scale data sets to train these systems allowing them to operate with a level of precision and depth that was previously unfathomable. Generative AI is not merely a technological marvel, but an influential force that is shaping various sectors of our society. Its impact extends beyond the confines of the tech industry, instigating change in diverse arenas, from healthcare to finance, from manufacturing to customer service. This transformative power of AI is not just a future prediction, but a present reality. In the healthcare industry, the utilization of AI is not just about automation, but about saving lives. It powers predictive diagnostics, enabling the early detection of life-threatening diseases. It is even used in formulating personalized treatment plans, thereby increasing the effectiveness of healthcare delivery. In the realm of manufacturing, AI is playing a crucial role in enhancing efficiencies and optimizing production. Predictive maintenance, enabled by AI, prevents unnecessary downtime and increases machine longevity. AI's algorithms analyze patterns and predict potential faults, allowing for preemptive measures, thereby revolutionizing the manufacturing landscape. At the heart of these transformations is generative AI, reminding us of the vast potential that technology holds in revolutionizing our world. AI is truly revolutionizing our world. The story does not end here. The prospects of AI, the future, are incredibly intriguing. Maximized processing power is foreseen with the advent of quantum computing. Researchers globally are putting efforts into developing general artificial intelligence, aiming to match the flexibility and adaptability inherent in the human mind. Of course, these advancements are not without their set of challenges, particularly those pertaining to AI ethics and explainability. These factors emphasize the requirement for a framework of ethical guidelines that address biases, promotes transparency, and ensures accountability. As we traverse through the chronicles of AI progression, we see a profound effect on our lives and the immense potential it holds to catalyze further transformation and innovation. Journey of AI, from its early theoretical concepts to its practical implementations, is a testament to human creativity and the transformative power of technology. AI manifests how technology has the power to mold our world. The future of AI, thus, doesn't promise developments, but it also presents a reflection of our capacity to innovate and transform. From its infancy to its current state, AI stands as a testament to human ingenuity and the power of technology to shape our world